All right, today we are going to get started with section 1.4, algebraic expressions. So the first thing we're going to do is define some of the following vocabulary words in your notebook. So we'll start with variables. So variables are letters that represent numbers. So the most common used variable and that we use a lot of times in math is x. But you could use anything, x, y, z, a, b, c, so on. Any letter of the alphabet that represents a number is considered a variable. Constants are plain numbers. For example, -1 is a constant number. 3 is a constant number, and so on. Any plain number with no variable is a constant number. Algebraic expressions are math sentences that involve variables, constants, and then operations. So let me write that down. For example, an algebraic expression could be something like 2x plus what? We have a variable in this expression, x. We have constants. We have one constant of 1. And then we have operations. We have 2 being multiplied by x, and then we have addition with 2x and 1. So an algebraic expression is just like a math sentence, but there's no equal sign with algebraic expressions. Terms are the separate little parts of an algebraic expression. For example, in my algebraic expression 2x plus 1, the terms are 2x, and then the other term is 1. So that one has 2 terms. So the terms are basically the separate parts that are separated from the plus signs or minus signs that connect all the different parts together in the algebraic expression. So for example, x squared minus 3x plus 6, or also known as x squared plus negative 3x plus 6, has 3 separate terms. If you're looking at that algebraic expression, the first term is x squared, since that's the very first term we see here in the expression, and it has a coefficient of 1. That means that there's an invisible 1 in front of the x squared. Whenever there is a coefficient of 1, then we don't have to necessarily write that. The coefficient means the number in front of the variable. So that has the coefficient of 1. The next term here is negative 3x. Now, it's very important to understand that I know that that term does say minus 3x, which gets confusing. That is it subtraction? Is it adding a negative? Well, it's the same exact thing. Subtraction and adding a negative is equal. So we can think of this as a negative 3x. So the coefficient of that is negative 3. And then the last term here is 6. This is a constant number. There are no coefficients in constant numbers. They're just considered constants. So 6 is that last one. In the first example, we are going to identify the terms and coefficients in that algebraic expression. So let me erase everything here and scroll down to example 1. Identifying terms and coefficients. Now, before we actually identify everything, we might want to look to see if we can combine like terms. So I'm actually going to start with example 2, combining like terms for this example. So we have here 3a minus 5ab plus 9a squared plus 4ab minus a. The reason why I'm skipping to example 2 first, combining like terms, is because we don't want to identify all the terms in this algebraic expression and all of the coefficients if we can make it simpler first. So to make it simpler, we're going to be looking at the separate terms and seeing if there are any terms that have the same exact variables. If so, we can combine those like terms and make the 2 terms or 3 terms down to 1 term instead of having to write multiple things multiple times. So let's start with 3a. What we're doing is we're looking for a term in this algebraic expression that also has just a plain a variable. Not a to the second power, not a to the third power, not a, b, just any plain term that also has just one plain a. So if I'm looking at this term here has one plain a, and this term here has one plain a. Because of that, we can combine these together. Combining like terms only works if the terms have the same exact variables. So 3a with a negative a combines together to be 2a. All right, moving down the line, I'm going to switch my color. Now I'm looking to see if there are any terms that are like with negative 5ab. That means there's one a, there's one b, and if I look here, we have a positive 4ab, so that one will be able to be combined with a negative 5ab. It's very important that you understand that that is a negative 5ab, not a positive, because to the left of it is the negative sign. And then that's a positive 4ab because of the plus sign to the left of it. So when I combine a negative 5ab with a positive 4ab, I'm going to get a negative 1ab. You can either just write that as negative ab, knowing there's an invisible 1 there, or you can put the 1 in front of the a like that to show it's a negative 1, either way. And then the last term that we have is plus 9a squared, which does not have any like terms because there are no other terms that would be able to be combined with that. Since it's a different type of variable, it has a square. So this would be the final answer when everything is combined. You can write it like that, or you can just write it as 2a minus ab plus 9a squared. Now, we will be getting back, once we get into farther into the chapter, we'll be writing, we'll learn how to write these problems in the correct form, but for now this is perfect. So now back to example 1, identifying the terms and coefficients. The reason why I wanted to do that now is because now we only have 3 terms instead of 1, 2, 3, 4, 5 of them from the very beginning. So now when we write the terms, the separate terms we have once it's simplified are 2a, negative ab, and a 9a squared. So we have these 3 terms. Instead of having to write all of them out from the beginning, 3a, negative 5ab, 9a squared, and so on, it might make sense to just simplify it first. It makes it easier. So the 3 coefficients we have once it's simplified are 2, negative 1, and 9. All right. So, looking at the next questions, it's asking us to simplify these by combining like terms. So let me erase this and scroll down so we can see all of them. How does this work? Yeah. Okay, so simplifying each expression by combining like terms. So we're going to start with 18z plus 14z. Now these are like terms, so we can just combine them together. We have 18 z's, we have 14 more z's. Altogether we have 32 z's. Like terms, basically you just add the coefficients together and keep the variables the same. The next one, we have negative 2x squared and 4x squared. Well, they have the same exact variables, so we can combine these like terms by adding their coefficients. Negative 2 plus 4 is a positive 2, so this will become 2x squared. And then the last one, we have to look for the specific like terms that can be combined together. I see a negative 3x to the fourth power, and then looking down the line, I see another x to the fourth power. That is just a positive 1. So negative 3x to the fourth plus 1x to the fourth will be negative 2x to the fourth power. Now looking down the line, I'm going to look for x's since that's the next thing I see. 6x, and right next to it I see minus 1x, or a negative 1x. Well, a positive 6 minus 1 will end up being a positive 5x. Then moving down the line, I have here 8. There's a plain constant, positive 8, and then a plain constant, negative 10. Well, 8 minus 10, or a positive 8 with a negative 10, will be a negative 2. So this would be minus 2 at the end. Simplified will be negative 2x to the fourth plus 5x minus 2. We're going to do a last example together, example 3, before you guys try some of these on your own. So let me erase this and then move on to the next page. So example 3. Remove grouping symbols and simplify each expression. So notice that the minus sign can be removed by using the distributive property, and the number you distribute is a negative 1. So looking here at this problem, it's asking us to simplify 3x minus, in parentheses, 2x minus 7. And it's showing us how we would do that. So to simplify this, basically whenever we have a negative sign in front of parentheses and there's no number there, we know that this number is actually a negative 1. So you can think of it as a negative 1 that needs to be distributed to everything on the inside of the parentheses. So whenever you have this, please make sure you use that distributive property and distribute the negative 1. That will make this expression turn into 3x, since nothing happened with the 3x, that's on the outside of that. But then we have to multiply negative 1 times 2x. Negative 1 times 2x is negative 2x. And then we have to do the negative 1 times a negative 7. Negative 1 times negative 7 is a positive 7. Or you can think of it as a negative 1 times 7, which is negative 7. And then minus negative 7 ends up being a plus 7. Either way, you should get this. Then, after you have this, you should look to try and combine like terms. The like terms I have here are 3x and negative 2x. 3x minus 2x, or 3x with a negative 2x, ends up just simplifying down to be 1x, and then the plus 7 would be the final answer here. So what I'm going to have you guys try next is simplifying each expression below. You might have to use the distributive property, you might have to multiply, and then I want you to combine like terms. So what you're going to do for these problems A through E is simplify by using the distributive property if necessary, then combine like terms.